Lesson 20 is change of base. So we're going to go back and talk about logs again. Change of base, graphing origin-centered conics on a graphing calculator. So graphing the conics, but using the graphing calculator to do that. So, first of all, if we go back to Algebra 2, I believe, is where you first learned change of base formula. Yeah, pretty sure that's an Algebra 2 thing. I mean, you would have used it or reviewed it in pre-cal, but, you know. Okay, so remember the change of base formula for logarithms. Okay, officially, on most calculators, you just have a log button, right? You have a log button or you have an LN button. Okay, typical calculator, you can't go in and change the base. So, the change of base formula allows us to change it so that you can put it in on a calculator, regardless of what this base b is. You can either change it to natural logs, where it's the natural log of x divided by the natural log of b. So natural log of the inside divided by the b, natural log of the base. Or you can use log base whatever, which if you're going for the calculator, it'd be log base 10, right? So log base 10 of x divided by log base 10 of b. Okay, yes?
So if you do alpha window and 5, is that not the same thing?
So on these calculators, yes, you can change the base. Is that what you're questioning?
Yeah.
Yeah. On these calculators, you can change the base. And I wouldn't have known where to tell you other than I know it's in one of the shortcut menus there with the alpha. Okay, so yeah, these calculators you change. However, that's not a typical calculator. If we grab the scientific calculators out that you would have had in Algebra 2, you can't change the base. Yeah, some of you guys found it last year, I remember. Or maybe we didn't. So.
I was just curious.
Yeah.
I feel like we'd mentioned it last year, but maybe not. Maybe I didn't actually mention it as a class. Okay. Very possible. Okay, so rewrite log base 4 of x using common logarithms. So, first of all, when they say common logarithms, they're wanting you to rewrite it using base 10. So natural log is base e, common log is base 10. So if we're going to rewrite this using base 10, how do I rewrite this? Yeah. Log of x, and officially when we do this, it's log base 10 of x divided by log base 10 of 4. Except, what do we know when the base is 10? You don't have to write the base in, do you? And so, probably more efficient to write is what he said to begin with, log of x divided by log of 4. Okay? Example 2. Estimate log of 67 base 4 by using a calculator. Notice it says estimate. Officially, what do I want you to tell me here? That you should be putting in what? .033. I have written down 3.0330 would be the 4th decimal place, so. Okay. Easy enough? Use a calculator to approximate 4 log base 15 of 6 plus 5 log base 4 of 7. Now, again, how can we use our change of base rules to do this? Thoughts? Okay, so that's what I was just thinking. You can move it. I guess technically you wouldn't have to move it here. And I think it should work out the same either way. And I'm kind of double checking myself here. In the power rule there, And he says we can move this 4 up to the 6 and the 5 up to the 7. And it will work. That is perfectly fine. What would be the other option? Yeah. The other option is to do 4 times log 15, or 6 over log 15, and then 5 times log 7 over log 4. Which is better?
Doesn't matter.
I don't have a better answer here. Okay? I think both are actually valid in this case. Now, I totally understand Nathan saying move the power up, because what do we so often need to do first? Move that power up. So, and the way I checked it is I just checked, I didn't do the whole thing, but okay, 4 times log of 6 over log of 15 is the same as log of 6 to the 4th divided by log of 15. And so that was kind of my double checking to make sure. So I'm going to write, just because it's not the one we probably think of as much, 4 times log of 6 divided by log of 15 plus 5 times log of 7 divided by log of 4. Now, I use log. Keep in mind you could use log base 10 or natural log. So just kind of a side note there.
What? Is yours in degrees?
No, my calculator happens to be in radians, but it shouldn't matter here.
Whenever I did it the other way, like the alpha, the second window, whatever, the alpha window thing, I got a different answer.
Interesting. Okay, so, for just that part, because that wasn't my whole answer.
Yeah, never mind. Yeah, the whole answer. Never mind.
So what is our whole answer when we add these two together?
9.66.
Yep. I have written down 9.6650 is the 4th decimal place. Is that the problem, Mallory? Yeah. In an effort to, try and be quick, I had just plugged in the first one just to see if they make sure, to verify myself before I continued, and I didn't want to, mistakenly say, oh yeah, that's fine, and then, yeah. In my mind it was perfectly fine, but, okay, so we're all good now, we got that? Okay. If log base B of 47 equals 17, what is B? Thoughts? Left, right, middle. Take it out of log form to an exponential equation form. That's a fun equation. How do we solve it? Well, that's what I'm trying to decide. If you take the log of both sides, you're going to have log of B, though. I'm not sure if that's going to get you there. I don't know. Make it.
But then would you just solve for B?
But I feel like that's going to put you in a vicious circle. Sharing the light. I don't know. I need a visual here. So, we take, what did you say? So, log...
I'm guessing that didn't work. It's first name.
And then you move the 17.
Yeah. But see, then... Because at B, you can divide the 17 over here. It would work.
That's what I'm saying. That's what
It would. Because log of B is going to be log of 47 divided by 17.
And then you divide by log.
No, you can't divide by log, though. No, wait. Left, right, middle. Because then you're going to have 10 to the log of 47 divided by 17 equals B. Personally, I like my way a lot better.
But your way does work.
But, I mean, we can double check this here with the correct answer. I mean, you know, if someone plugs in their calculator, we can double check it. Mathematically, it seems sound to me. I don't see any reason it wouldn't work. I'd be shocked if you get a different answer there. Yeah. Okay, so let me ask this. Okay. Let me ask this. Back to my b to the 17th equals 47. What if this was b squared? You would take the square root. We have fancy calculators that would allow us to do the 17th root.
I didn't know if the rest of it was saying.
Like that.
Just 17 first and got something.
So now the question is, does the 17th root equal this funky thing up here? I have a feeling it actually probably will.
Yeah, that's like 2, 5, 4, 2. That's what I got.
Okay.
There we go.
17th root of 47.
So 1.2542 is our agreed upon answer. So taking the log of each side and then doing a left, right, middle, it does work. It was a little bit more work, and it really had me questioning if this was going to work. I personally like the 17th root a little bit better. But, you know, whatever makes you guys happy there. Well, this is where, notice, I was afraid to write it out in the notes because I thought if this fails, then I've got all that, you know. Which, you know, nothing wrong with putting it in the notes and just scribbling it out, but. Okay. Graphene.
You should just leave
Let's
the
leave that
log
in
of
there.
17
Just a minute,
try to have
Charlie.
your next error solved.
Yeah, my pre-cal kids haven't reviewed logs yet,
That's
and
why it's a challenge.
they're not going to remember.
That sucks. Well, they should have the fancy calculator.
So I just see that to look forward to.
Okay, so in order to graph conic sections on a graphing calculator. I'm in Monday and I'm still tongue-tied. Okay, what has to be true to use our calculator to graph something? It has to be y equals. So, first of all, we're going to try graphing x squared plus y squared equals 4. Now, it kind of already gives it away, but x squared plus y squared equals 4. Can you visualize what we're going to be graphing here? A circle centered at, no, centered at 0, 0, because there's no x plus or minus anything or y plus or minus anything, with a radius of 2. Okay, now, how do we get the calculator to verify that? Equals 4 minus x squared, and then we're going to take the square root, and then y equals what? No. No.
4 minus x squared. Yeah! Plus or minus, my bad.
Okay, so I heard all the pieces out there eventually. So first of all, when you take the square root in an equation setting, you have to include both the positive and negative roots, so plus or minus. Now, mistake I heard out there, this is a difference, 4 minus x squared. You cannot take the square root of 4 and the square root of x squared and just say 2 minus x. Unless this factors into 2 minus x quantity squared.
Didn't we do something like this on homework?
I don't know.
I think we used the exact same equation. Let me find
Okay,
It's always disappointing.
so now, how do we punch this into the calculator?
Just do it.
Just do it, man.
We have to put 2 of them, 2 different equations.
Okay, that is the point I was trying to get to.
Get hopeful.
There is no plus or minus sign. Okay, so when you type this into the calculator, you're going to have a y1 and a y2. Yes?
Yep.
One is square root 4 minus x squared. Y2 is negative square root 4 minus x squared.
Graph it. And that's a beautiful circle. Looks kind of like a football.
Okay, so that brings up another question. Okay, why does it look like a circle?
Because we're not zoomed in.
Because we have rectangles.
Why do they put a circle pizza in a square box?
And cut it into triangles.
Because it's too much manufacturing to make a circle box.
I hate you, Trevor.
Okay, so if I graph this, it does come up looking more ovalish, but yet what do we know it's supposed to be?
A circle.
A circle. And unfortunately, it's not acting as a circle. Okay, so the settings on our window automatically go to 10s, right? Negative 10, positive 10, negative 10, positive 10. However, is our window square? Our window is rectangular in that can you guys compare? Look at how the tick marks on my x-axis are more spread out than the tick marks on my y-axis. Okay, now, go into your Zoom windows. Go into Zoom. Number 5 is that's going to square up your window.
Now that John is a circle.
And now, it looks like a circle. And now, also notice my tick marks are evenly spaced. Okay?
How come it leaves so much white space?
Zoom 5.
Okay, that's fine.
Yeah.
Now it works.
Okay, you must have not exactly hit that. Okay, now, if you wanted to zoom in, I don't know how that would do. I don't know if that would kill your square or not. Does it keep it square if you just do a zoom in?
Yeah.
Okay. You could probably do a Z box.
How come there's so much white space where values don't work?
Z-Box makes
What do you mean? What'd you say about Z box, Logan?
Makes it back into it.
Does it? Okay.
Oh my goodness.
Oh, and yeah, the more you zoom in, the bigger the gap shows. But really, the only value that doesn't work there is,
Below the x-axis.
yeah, it should go all the way.
Z-Box makes your window, or you're zooming in.
Now, one thing. I don't know if anyone caught what I did. Did you guys see what I did on my y equals window?
Yeah, I saw that and I was like, how did you do that?
I did something like that.
Okay, so this works if all you need to do is do the exact opposite. But if you have a big, long, ugly radical, it would. And so I'm sure it's somewhere, but I went into the shortcuts. It's alpha F4. So alpha trace. And there's Y1, Y2, Y3,
That's what those are. I've seen those. I just don't know what they're.
And so you can pick that, okay, I want to take Y1. It's like, I could take here that I want to take Y1 and I want to shift it up 6. And then it should take, shoot, I hit the wrong thing. Wait, it didn't, well, we're not even going to be able to see the third one because
It shifted up 6.
it's just, I thought I hit, it doesn't, okay, if I hit zoom 5, it's not zooming back out for me. Interesting. Because normally I would think zoom 5 would kind of be like a zoom standard where it resets it.
It probably just squares whatever you're in.
Okay, so now I'm just back to a standard zoom and notice, hey, there's my one move 6 up. So it's just saying you can take that graph and do whatever. Okay. So, we already talked, you should have had a circle that had radius 2.
I have hiccups. Is that a symptom of COVID?
Let me check my paper here.
Oh my god.
Let's see. No, I do not see hiccups. You're safe. I don't have to send you to the nurse. I don't have to send you home.
Just imagine if the hiccups were a symptom. That'd be stupid.
It's so weird.
Natalie would be in such trouble.
So how do you think that was- it's like, oh,
I hate hiccups. It literally feels like I'm dying on the inside.
Natalie gets the hiccups so easily. And just okay, guys. One last one. Then we're gonna have extra time today. Okay, using a graphing calculator, graph the curve given by this. Now, okay, let's see how well the pre-cal stuck. What is this? Before we...
No. Don't just ignore me. I'm just saying things.
What'd you say?
I don't remember.
Okay, you guys don't remember what this one's going to look like?
It looks like a curve.
This goes back to our conic sections.
Right? Is it a curve? Is it a circle?
Everything's a curve of some sort, but...
Boom, alright.
Okay, so it's not a circle because these values are different. Okay? But x squared and y squared are added together, not subtracted. Oval, what's the official name of the oval? Ellipse. Yeah. If this was a subtraction sign, if this plus sign was a subtraction sign instead, it'd be a hyperbola, where you had the two things flip out instead of together. Ellipse. You were my eclipse king last year, weren't you? Okay. That's coming back to me too. Okay. How are we going to use the graphing calculator to graph this?
We gotta fix it.
Gotta fix it. How do you guys want to fix it?
Shift the first term over.
I wonder if I spelled the ellipse right. Is it 1 L?
I think it's 2.
I think it's 2.
Okay, so I'm hearing shift the first term over. Are you guys just going to leave the fractions in there and work with the ugliness?
Yeah.
That's facts. What Daryl said was a fact, though.
That you can just type it. I'm just thinking, how ugly is it going to be to type it in the calculator?
That won't be that bad.
Honestly, I think it's going to, going off the top of my head, I think it might work out the same. So, okay. You guys want to work with it as is. So, that means I'm leaving it as y squared over 9 equals 1 minus x squared over 4, correct? Then what? Now we're going to multiply by 9.
Yeah.
So then it becomes y squared equals 9 minus 9/4 x squared. And then final step, square root. So y equals plus or minus the square root of 9 minus 9/4 x squared. And actually that did work out the same as what mine was going to end up, so. So, it really comes down to getting that first one typed in right, doesn't it? I'm going to go ahead and go to standard because what have I taught you over the years is you just automatically go to standard. Now, I agree, it does look like a circle, but count. On the x-axis, it goes out 2 either way. On the y-axis, it goes up 3. So is that really a circle? No. So, kind of backwards, but yes, if you go to the square screen, zoom 5, now that will make it look ellipse-like. You could. I mean, it technically would make it more official. I don't know. I'm sure at some point we'll find some way that is not in our best interest. Okay, I'm going to sketch my ellipse here. What was this? 2 on the x and
3 on the Y.
3 on the y.
That was beautiful.
And in case you care to write it down, it worked out to be an ellipse.
Not odd reading, I just stabbed it.